Hey guys, welcome to today's lesson. We're looking at factorising algebraic terms. We're going to look at some simple ones to begin with, but then we're going to get some fairly challenging questions. The first example I'm going to look at is a nice easy one, 3a plus 6. So what does it mean to factorise? Hopefully remember factorising has the word factor, which means we're looking for a number or a letter that goes into both terms. If I look at this case, we've got a 3 goes into 3 once and a 3 goes into 6 twice. So we can factorise the 3 and put it outside the brackets. And then often what we do is we test it. 3 times something makes the 3a. Well, that's 3a. As you can see, 3 times a. I've got a plus in the middle, and 3 times 2 makes the 6. So my answer there, as you can see, is just 3 outside of a plus 2. So again, factorising just means to put back into the brackets as opposed to expanding, where we expand the brackets out. So we get cases like that first one where you've got a common number. Sometimes you might get a question like this, a squared plus 3a. In this case, there's no other number apart from 1. It's not going to really help us. But what you might recognise is I've got an a squared and I've got a 3a, which means that a goes into both of those terms. A times a makes the a squared, plus and a times 3 makes the 3a. So again, it's fairly straightforward. A slightly more challenging one will be combining both the numbers and the letters. For example, 3q squared minus 12q. In this case, you might recognize that 3 is a factor of both. I'm going to put the 3 at the front. Q is also a factor of both. Open my brackets, 3q multiplied by q, that makes 3q squared. There's a minus, I'll put a minus there. 3q times positive 4 makes 12q, and there we go, we have our answer. And it's often easy, if you want to double check, you can quickly expand it, because probably like me, you're a little bit better at expanding. We can expand the terms and double check that we have what we started with. So it's very loosely based on, I guess, the factorising of algebraic terms. You can get harder questions, of course. For example, we'll go through example 4 here. You might have something that looks like this. 3a squared q to the 5 minus, we'll do, let's say, 15a q squared. Now, this is certainly a more challenging question, and at I guess a year 9 standard and above, maybe challenging year 8. So first of all, if I'm factorising, I want to put these back into my brackets. So I first look at my numbers. We've got a 3 and a 15. So what's a common factor between both of those? Well, hopefully you recognise that 3 goes into both. I've got a squared and a. So what goes into both of those? Well, a to the power of 1, or just a. And this is the tricky bit. I've now got q5 and q squared. Now, at first glance, you might say q goes into both of those, but in fact, there's more than just q. We can actually say that q squared goes into both of those, because there's 2 of them here and there's 5 of them here, so we can actually take 2 of them out. I'm going to open my brackets. 3 times 1 makes 3, so I don't have to have a number there. A times a makes the a squared. And then q squared times what makes q5. Now that's the hard part. So what happens when you times the letters together? What do you do with the powers? Hopefully, in order to make 5, you recognize that when we multiply, thinking back to a to the m times a to the n, when you multiply, you plus the 2 powers, don't you? Okay, so for example, if we had q squared times q3, that would make q5, because we would add them together. Which means if I've got 2 of them here, it means I'm missing 3 of them there. 2 plus 3 makes the 5. There's a minus, so I'm going to put a minus here. And then the next bit, we'll recognise 3 times 5 makes 15. aq squared, I've already got aq squared, so there's no need to put anything else there. And then I've got my answer there. Okay, and look, it's important to fully factorise as well. A few of you might have something that looks like this, 3aq, and then you would have aq4 minus 5q. And the issue there is you've still got a q in both of them. There's a q that goes in both of these two. So you need to take everything out that you possibly can. Okay, it needs to be what we call fully factorized. And it doesn't even need to say fully factorized, but you must fully factorize every time. We'll get maybe another harder question. We've got e.g., I think this has come up to, let me just check, 5 now. Okay, so e.g. 5. Apologies there. Okay, e.g. 5, negative 6q squared plus, we'll do, let's say 30q. So if we want to factorize this, now if you start with a negative number, it's a good habit to get into by factorizing the negative out to start off with. Now what goes into 6 and 30? Well, hopefully you recognize 2 goes into both, that's true, but 3 also goes into both, so we need to take the highest number. And then I've got a q that goes into both of those. So now what can I times the minus 3q by to make negative 6q squared? Well, 3 times 2 makes 6, and I'm missing a q there. Now the next part is a bit more challenging because we need to do minus 3q times something to make 30q, but it's a plus 30q. So a negative times a negative makes the positive, and then 3 times 10 makes 30, and we've got the q there. And again, if I expand that out, we can make sure that we make the above term. Again, I don't want to have a q there because that makes q squared. And if I have a plus in the middle, that would make it negative 30q, not the positive 30q. So again, I'm just going to show you if I expanded that. Negative 3 times 2 is negative 6q squared. Negative 3 times negative 10 is positive 30q. And you can see that's exactly what we had to start off with. Okay, now that of course is a slightly more challenging question. They do get a little bit harder as we go down the track, but for this lesson, we're going to leave it at that point. I guess actually, you know what? I'm just going to do one last one. I'm going to throw this in there. We're going to have 3 terms. I'm going to say 6q to the 4 plus 12q to the 3 minus 20q. Just because sometimes you might have more than 3 terms, and again, we're always looking for what we refer to as a common factor. Okay, well, what goes into 6, 12, and 20? Well, 2 goes into all of them, but like last time, that's not enough. 3 goes into all of them. Actually, no, it doesn't, does it? It is 2. There you go. So 2 is going to be our maximum. So 2 goes at the front. Now I've got a Q, a Q3, and a Q4. Well, in that case, we can only just take one Q. If I take 2 of them, although it goes into the first 2, it doesn't go into that last one. So I'm going to open the brackets. 2 times 3 makes 6. Then I'm missing 3 of those cubes to make the Q4. Plus 2 times 6 makes 12, but I'm missing 2 cubes to make the Q3. Minus 2 times 10, and that makes negative 20q, and I'll look through there. And if you're not sure if you've got all the most numbers out you possibly can, look at the numbers here, noticing that I've got 3, 6, and 10. Nothing goes into any of those 3. I've got Q3, Q2, and no Qs. Nothing else goes in. Therefore, that is my most simplified answer, and I have to stop there. Okay, guys, that is a basic understanding, I guess, of factorizing our algebraic terms. Slightly harder than a couple of my other previous lessons, but certainly that's a good platform for us to go on when we're going to start working into factorizing harder algebraic terms. Any questions, please email me or ask me in class. Otherwise, have an awesome day, and I'll speak to you later on. Thank you.